Okay, so this is applying those transformations instead of to a bunch of points. It's like here, we're going to take a graph and we're going to do these things. You still need to know the points. Okay, it was a little bit easier on the question before because with these questions, you kind of have to have the base graph memorized. So our base graph would be x and then f of x, which is just the square root. And remember our points for this one were 0, 1. I can take the square root of 4. I can take the square root of 9. 0, 1, 2, 3. So you have to have those points kind of on hand and in your memory banks because then what you're going to do is you're going to be applying these different functions. Sorry, different transformations. So it wants us to sketch this graph using a series. I want to see all the parts. There are going to be 1, 2, 3, 4, okay, 5. 5 different graphs on this. We start with y equals f of x, which looks like that. Okay? Then we are vertically compressing by a factor of a half. We are going to multiply our y values by a half. So these original y values are going to get squashed. If you're multiplying by a half, you're getting smaller. So instead of being 0, 0, well, 0, 0 is going to stay the same because we multiply by half. Instead of being over 1 up 1, it's going to be over 1 up a half. Instead of being over 4 up 2, it'll be over 4 up a half of that, which is 1. Now, the 9 is at 3, so it'll come down to 1.5. Okay? So that's what our graph looks like. Okay? And you would just guesstimate at the 1.5. Next transformations, let's go inside. Okay, we're affecting our x values if we're doing an inside transformation. How do we know it's inside? It's under the square root sign. Even though the -1 is technically in the bracket to the x, the 2 is still under the square root sign. And remember, square root signs act like a bracket. You have to do all the math in there first before you could do like this times or this subtraction. And then you'd have to do the times first and then you do the subtraction. Okay, anyway. So it's a horizontal opposite. If you're multiplying by 2, usually you're getting bigger. We're going to do the opposite. Horizontal compression by a factor of 2. We are going to multiply by 1 over k, which is 1/2. That means your x values are getting smaller and they're getting cut in half. This is, well, that's an ugly one. 0's fine because it stays at 0. The 4 is the only nice one. The 9 is going to be at 4.5. So the 0 is going to stay here. And then where's a nice, our 1, instead of being 0.1 at 0.5, it's going to be 0.5 at 0.5. Instead of being 4 at 1, it's going to be half of that, 2 at 1. Instead of being 9 at 1.5, it's going to be 4.5 at 1.5. We are taking our x values and we are squashing them. And that is what would happen. You can see how green has gotten. It gets higher faster. Normally, remember with red, it was 4 at 1. Now it's green is 2 at 1. So it's taken those x values and it's shunted them by a half. Now we are horizontally translating 1 unit to the right. If it's negative, we do the opposite. So we're taking green and we're going to move every point 1 to the right, 1 to the right, 1 to the right, 1 to the right. So our blue shows that the green has been taken and moving 1 to the right. And moved. Moving is not a word, Megan. Okay, you can do it, you can do it, you can do it. Oh, that's not better. It doesn't like that I'm on a table, like my tablecloth. It's got a thing with my tablecloth. I'm just going to bring this up because you know what's coming. Okay, last one here is -2. We're going to take all of blue and we're going to move it down 2 units successfully. Purple. There we go. So blue was taken and moved down 2 units. This is the final equation. Purple is what we want to get to. Okay? But this would be a good example of a series. You had your base graph, then you had your vertical stuff, and then you had your horizontal stuff, then you had your horizontal translation, then you had your vertical translation down.